So we got to look at Chapter 7, Topic 6, which is the applications of sequences and series. It's essentially how you can use applications and series in like a word problem or something like that. The general idea when approaching these types of problems will be, well, let's take a problem first and I'll explain. So this first problem says an auditorium has 15 seats in the first row, 19 seats in the second row, 20 seats, 23 seats in the next row, and so on. 23 seats in the next row, and so on. There are 20 rows of seats. The first thing you're going to want to decide here is this arithmetic or geometric? So first we set up the sequence. So 15, 19, 23, etc. Okay, so this is the sequence that we have represented here. We can see that this is actually an arithmetic sequence. Okay, there's a common difference here. There's a common difference of 4 that's being added each time. Plus 4, plus 4, plus 4. Each one of these terms in the sequence actually represents a row. Okay, a row in the auditorium. This is the first, there's 15 seats in the first row, 19 seats in the second row, 23 seats in the next row, okay, and so on. There are actually 20 rows of seats. So the number of rows, which is n, the number of terms, in this problem the terms are the rows. Row 1, row 2, row 3. So there's 20 rows. So we're looking at an arithmetic sequence here. So let's look at letter A. Letter A says, how many seats are in the last row of the auditorium? Okay, so this is basically asking us how many seats are in the 20th row. Okay, so that'll essentially be the 20th term in the sequence, A20. That would be the 20th term in the sequence, the very last term of the sequence. And we can find the 20th term of the sequence by just using the formula for an arithmetic sequence. So the 20th term of the sequence can be found by taking the first term and adding the difference n minus 1 times. So n is 20, so we'd add the difference 19 times. Okay, so we just need to plug this into a calculator, 4 times 19, and then add 15. So 4 times 19, 76, plus 15. So there's 91 seats in row 20. Row 20 has 91 seats. Okay, row 20 has 91 seats. All right, next part of the problem says how many seats are in the whole auditorium? Okay, how many seats are in the entire auditorium? So this is actually the series when you think about it, because what you're going to want to do is you're going to want to take the number of seats in the first row, add the number of seats in the second row, add the number of seats in the third row, and so on until you get to the last row, which in this case, the last row had 91 seats. You're actually adding all of these together, every single row. So this is a series. So we need to use the series formula, n over 2, a1 plus an, the arithmetic series formula, to calculate the sum. Okay? So the sum is equal to the number of terms, there's 20, divided by 2, and then multiplied by the sum of the first row, which is 15, plus the last row, which there's 91. Okay, so this is 10 multiplied by 106. Okay, so 1060. There's the sum is 1060. So there's 1060 seats in the entire auditorium. And this was the series because the question, since it said the entire auditorium, it wants us to add all of the rows together. So that's a series, 1060. Okay, moving on to the next problem. Population of a colony of bees doubles each day. The population on the first day is 5. What is the population of the bees on the 10th day? Okay, so essentially it's doubling each time. So on day 1, which is the first term, population is 5. Day 2, which is the next term, this is day 2, the population is 10. The next day, day 3, population is 20, and so on. Okay, so we're looking at a geometric sequence here. This is geometric. Because it has a common ratio, it's being multiplied by 2 each time. The ratio is 2. And of course, the number of terms, each term is the population on a given day. So this is the population on day 1, population on day 2, population on day 3. We're looking for the population where the 10th term, day 10, all the way over here. So this would actually be us just finding the 20th term. We're looking, or sorry, the 10th term. We are looking for A10 in this sequence. That is the population on the 10th day. This is not a series. We're not trying to add all of these individual days together. Okay, that doesn't make any sense. We're not trying to add them all together. We are just looking for the population on day 10, so that's A10. But remember, this is geometric, so we have to use the geometric formula, which is A1 times R to the n minus 1. So A10 is equal to the first day, 5, first term, which is 5, multiplied by the ratio, which is 2, and the ratio is raised to the n minus 1 power, so 10 minus 1, which is 9. Okay, do the exponent first, 2 to the 9th power. So 2 raised to the power of 9 is 512. Multiply that by 5. So we are looking at 2,560 is the population on day 10. Day 10 population is 2,560. Problem number 3. John deposited $10,000 as his initial investment into a savings account. Each year, he adds $1,250 to his account. How much money will be in John's account on year 20, or in year 20? Okay, so we got to think of it this way. Each term is the year. Okay, so year 1. Year 1, he puts in $10,000. Each year after that, he adds $1,250. Okay, so in the next year, he now has $11,250. This is year 2. So year 1, year 2. In the next year, he has $12,500. So that's how much he has year 3. Okay, so if we look at this sequence, ... we can see that this is arithmetic because it is increasing by a set amount each time. We're adding $1,250 each time, $1,250. So this is arithmetic. Now we have to decide if we're looking for a specific term in the sequence or if we're looking to add the whole sequence together. Are we trying to add all these terms together? Well, no, that wouldn't make any sense because all we're looking for is the 20th term over here. We're looking for A20. We're looking for how much does he have on this specific year? How much does he have in this specific year, the 20th year? So we will have to use the arithmetic formula for calculating a specific year. So that's the nth term, this term over here, is the first term plus the difference multiplied by n minus 1. So in this case, the 10th term is equal to the first term, 10,000, plus the difference is 1,250, and that will be multiplied by 1 less than the term number, so in this case, 1 less than the term number is 9. Okay, plug this into the calculator. So 1,250 times 9, and then add 10,000 to that. So 21,250 is how much he would have. Okay, wait a minute. Sorry, that's actually the 10th year. I messed that up. I'm thinking of a different problem. We're looking for the... Okay, so this was actually supposed to be 19. My bad. Because we're looking for the 20th. 1 less than 20 is actually 19. I thought that looked a little bit strange. So that's 1,250 times 19, and then we add the 10. Okay, so 33,750. Okay, so I made a small mistake there. I forgot to put the 1 in front of the 9 because it's supposed to be 1 less than the term number. We're looking for term number 20, so the number of times that we add the difference should be 19 times that we add the difference. So 33,750 is how much he has on the 20th day, or 20th year, my mistake. All right, last example here. So you're trying to save money. How much money would you have after 15 days if you set aside 15 cents on the first day? Okay, so first day, we're setting aside 15 cents. So 15 cents. The next day, second day, we are setting aside 45 cents. That 45 cents is now being included with our 15 cents. All right. The next day, this is day 1. On day 2, we add 45 cents to that. On day 3, we add $1.35 to that, and so on. Okay, so each day we're adding more to the money that we're putting aside. Now we can see, since we're adding each individual term together, the first term being added to the second term, being added to the third term, this is actually a series, okay? Because we are trying to add each specific term together. Now we need to know if it's arithmetic or geometric. Well, first of all, if we check to see if it's arithmetic, if we go from this term to this term, it's increasing by 30 cents. Okay, from 15 cents to 45 cents, that would be 30 cents. Well, if it increased by 30 cents again, this next term should be 75 cents, but it's not. So this could not possibly be arithmetic. This has to be geometric. This has to be geometric. So the next thing we would have to do is figure out what is the common ratio here. Okay, what's the common ratio? And very easy to find the common ratio. Just take a term and divide by the previous term. So the ratio would take one of the terms, 45 cents, and divide by the previous term, which is 15 cents. 45 cents divided by 15 cents, that is 3. This is being multiplied by 3 each time. Okay, 15 cents times 3 is 45 cents. 45 cents times 3 is $1.35. Okay, so the ratio is 3. Now, since this is a geometric series, we have to use the geometric series formula, which looks like this. The sum is equal to, in the numerator, a1 times 1 minus the ratio to the n power. In the denominator, 1 minus the ratio. Okay, so we're going to have to do that. So we know what the ratio is, it's 3. We know what the first term is. First term is 15 cents. The only thing we're missing is the number of terms. And the problem tells us we are looking to save for 15 days, so there's going to be 15 terms here. All right, so let's do our sum. The sum is equal to, in the numerator, we have 15 cents multiplied by 1 minus the ratio, so 3, and that's going to be raised to the n power, so 15 power. In the denominator is just 1 minus the ratio. Okay, at this point, we just need to calculate this. Okay, so I'm going to have to put that down for a second and bring up the scientific calculator here. So let's see what we have if we do this. So well, we need numerator and denominator. Okay, 0.15 multiplied by 1 minus 3 to the power of 15. And in the denominator, we have 1 minus 3. Okay. Now, most of the time, we would turn this into a fraction. However, and I can't even see it where it is. However, since the context of the problem is dollars and money, we don't really write dollars and money as a fraction. So we're going to leave it like this. 1,076,167.95. Okay, so if we look at this a little bit closer, we see that he will save $1,076,167.95. Okay, that is an absurd amount of money that he's saving after only 15 days. Okay, he only started with 15 cents. Okay, 15 cents is how much he started with. And doing this pattern, he saved over $1 million. That's kind of crazy. Well, anyways, so this one was a geometric series. We had to use the series formula, and we calculated our series as our answer here. All right, and that is how to use geometric and arithmetic sequences and series to solve problems.